start this video by asking you a question. What's the smallest object you've ever seen? Pause the video and come up with an answer. Maybe you saw a bacterium or another tiny organism like a tardigrade, or maybe even a speck of dust. You might have seen an individual cell or a large structure within that cell if you looked at a sample through a microscope in one of your science classes or perhaps in a museum. Truthfully, I'm not sure what the smallest thing I've seen is, but I think it's probably the individual bacteria that I took pictures of during my summer research way back in college. You're not alone here if you're wondering what's the smallest thing you've ever seen, and maybe you're not 100% sure. This is one of the many questions that have preoccupied humans for years, even back to ancient times. This is the thought that led scientists for centuries to wonder, what are the units that make up the stuff in the world we see? Or, as the fancy word for stuff we use, matter. Specifically, how can you cut matter down to individual substances or elements? And then if you have an element, how small can you chop it down and allow the element to still be itself? So to recap, all the way back to ancient Greece, the first record we have of people thinking about the atom and some incarnation dates back to 380 BCE in Greece. Philosophers were talking about the idea of atomos, which is Greek for indivisible. This is the concept of the smallest unit that you can cut an object down to and still have the object be itself. So we had a body of philosophers theorizing about the smallest unit of matter. But we can't call this process science. Why? Well, these certainly were ideas that had a rationale backed up by biological evidence. However, there were no experiments that were performed to test the idea. What I mean is, let's take it back to sourdough. It would be like if I ate or looked at a loaf of sourdough bread, I wrote a recipe myself for that bread based off what I thought might work, but then I never actually tried to bake the recipe myself. I'm not trying to trash talk the ancient Greek philosophers. We don't consider this to be science in the sense of modern word because the scientific method, as we know it today, hadn't been developed. But also partly because the ancient Greek philosophers didn't have the instruments they would have needed to make discoveries about the structure of the atom at that time. It wasn't until the Enlightenment and the 16 and the 1700s, that the scientific processes that we know of today, specifically the scientific method, came into being. We started to make progress about what matter in the world might be made of and how elements are involved. But more progress on the structure of atoms themselves would come later after the Industrial Revolution. In 1805, we saw a major breakthrough that changed the way we knew the atom. An English school teacher and scientist, because, scientists were casual and part-time back then, used the data from others' experiments, but also data from some of his own, to come up with 4 tenets for modern atomic theory, or rather, these are the 4 that still stand today. First of all, elements are made up of atoms. Atoms from the same element are identical, but they're different from the atoms that make up other elements. Atoms combine in whole number ratios to make compounds. And finally, in chemical reactions, atoms are combined, separated, or rearranged. From Dalton's theory, we were able to define a chemical element, or those blocks that we see on the periodic table. An element is a substance composed of one type of atom. And we also were able to talk about how atoms could combine to make different substances. Now, later on in the 1800s and early 1900s, and the Industrial Revolution occurred, and we saw in the rise in the technologies that were available. We got canal boats, then trains, then automobiles. In this class, we'll learn about the new dyes that were available as a result of oil refining. But along with this came new instrumentation that allowed us to dissect and characterize the structure of atoms. Next week, we'll start by diving in on the structure of atoms and eventually how the structure of the atom influences how it acts. But we are going to put the atom on hold for now and instead learn about the scientific method, or the method that was used to help us learn more about the atom.